and power are very important in our facility. So without electricity, whether you like it or not, put all the equipment together, all the installed equipment. Without electricity, this equipment is as useless as nothing, because nothing can drive them. And the reason for this course, why you should pay attention to electrical system and power maintenance in your building. So that's brief introduction. So at the conclusion of this course, participants will be able to understand the basis of electrical energy and power. You'll be able to carry out load analysis on your own. Energy analysis and why you should do it is important. Power factor as a function of generator size is determined. Most people don't know how to determine the size of a generator in a building, or in a facility. At the end of this class, we're able to know how to determine that. Various sources of power and its advantages, various generator components and their functions, the importance of equipment maintenance. Why do I need to pay attention to maintenance? Transformer and its function. And the last part of this class will be earthing and its importance. Why do I need to earth my system after installation? So module 1, introduction, definitions of power generation as a network of interrelated equipment, sources of this power, type of power. We have direct and alternative power, which is DC and AC power. Module 2 will be component of power. What makes up these components? What are the things involved in power system? We have the load, the conductors, electrical installation and protective devices and their usefulness. We have the radial system of installation and the ring system of installation. Why should I prefer radial or ring over each other? We have the distribution board and circuit breakers. So why should I stick to a circuit breaker rather than a fuse? So in module 3, we talked about generator maintenance and diesel management. While module 4 will be focusing on earthing and grounding system. Why is earthing important in my facility? So I would like to start by defining power. What is power system? The interconnection of electrical components. For supply, transfer of electric power. What this means is that where you are generating your power from may not be where it is being needed for consumption. So you have to generate and transfer your power. For example, your small generator at the corner of your building, the generator is there, but that is not where the electricity is needed. The electricity is needed either in the office, the MD's office, the accountant office, or wherever they need it. So you have to generate and transfer from where your consumers are. Like in production, it's that producer have not produced anything until it gets to the table of the consumer. So that is economics. The same thing applies to your power. You are not generating for yourself, you are generating for end users. So the operation of power system generation, the process of transforming energy into electrical form. And this energy are divided into subsystems that produce electricity. So, like a brief introduction I made to you, this is the layout. We have the generating power here. That's the power station, like the small generator I made mention of. So we have the generating station here. We have the power transmission that transmits power from where it is generated to where it is needed. So these are various sources of a power generating system. Do we get that? Hello?
Yes, sir. Yes, sir.
Okay,
Yes.
this is the network of electricity generation and distribution. So this is the powerhouse, like the Kainji Dam or the Shiroro Dam, is being generated and taken through this transmission line that you see when you are traveling along Nigeria roads. So to commercial customers and the residential customers. Electric power is a product of the current and the voltage. This is what makes up electricity. The product of voltage and current put together, that gives you electric power. So we have direct current, which is the DC. These are produced from batteries and a rectifier. We have direct current. They provide a constant current or voltage. This for the voltage, the electricity that is derived from this source is very clean, it's constant, uninterrupted. That's what we use in our IT system, servers, rooms, and IT system. They are generated through battery. Most computer and digital equipment use DC power. We have another source of power, which is alternative power. They transmit power over long distance, like the one we saw here. They transmit power. This is alternative power. It's different from the DC power. So they transmit power from to a very large, a long distance. So they are generated through an alternator. The equipment that make use of this type of power are the refrigerator, the air conditioner, and the lift, as the case may be. Anything that has to do with three-phase make use of this alternative power. They are not as clean or as constant as the DC power. They are alternative, they are sinusoidal. So they are not clean until you make, that's why we deploy UPS to rectify this power to what we actually need in our building, and batteries. So like I said, we have sources of power that are more than one, depending on what your organization, what you are recommended for your organization to adopt. We have the solar system of power, we have the thermal system of power, we have the wind turbine, we have the inverter, the batteries, and so on. So there are power which are embedded in the source that generates it. So they drive equipment inbuilt, like the welding machine. They generate their power. So you don't need to have external source of power before you can operate such machine. There are some that are external, like your lift, are operated by external power source, like your generator in your building, your transformer, and co. So we have loads. What are loads? Loads are anything that draws current, that require current to be driven. They are called loads. So load system delivers energy, a power system delivers energy to load. Like your computer is a load to your generator. Your AC is a load to your generator. Your fridge, your washing machine, they are loads to your power system. Load ranges from industrial equipment to household appliances. So load are expected to run at a certain number of frequencies and phases. What this means, every load is designed to operate at a frequency, a specified frequency. So anything that is out of this range, the frequency is usually between 48 and 52. Anything that is out of this range, the equipment will not work. They might be working, but they will be operating at a higher cost. That's why most people don't know why their bills are very high at the end of the month, because they don't pay attention to the frequency that they are operating on the type of voltage, output voltage that they are operating on. So if you run on a very low voltage with your equipment, you will incur more cost, because it will take a longer time for your equipment, just like your cooking, your electric stove. If your voltage is very low, it's going to take you like 4 or 5 hours to cook your food or to get your food ready if its voltage is of a standard value. So it will take you a shorter time to prepare your food when you have a standard voltage like 240, 230, as the case may be. So the operating frequency in Nigeria is usually 50 hertz, while the operating voltage in Nigeria is between 220 and 240. Anything outside this is regarded as abnormal voltage. So loads are expected to run at this value. Any appliance must have a specific wattage, like your electric iron. That's why they said AC 2 horsepower, 1.5 horsepower. So they are designed to operate at certain power. What 2 horsepower can do, 1 horsepower cannot do it. And the volume of electricity that is needed to drive your 2 horsepower is higher than that of 1 horsepower and 1.5 horsepower. So when you are asked to specify which equipment should I buy, you have to know the size of your generator. Like for 10 kVA cannot take more than 2 AC. If you go and buy like 2 horsepower AC, your 10 kVA generator may not be able to power 2 of them. But if you have 1 horsepower each, your 10 kVA can successfully power those 2 generators. So that's why you need to pay attention to this labeling that you have on your equipment. So they play a significant role in our facility. We have conductors. Conductors are wires or cables that take electricity from where it is generated to where it is needed. We have protective devices like the fuse and the circuit breaker. They prevent damage during failure or injuries. A typical protective device is the fuse, but fuse is no longer in use in modern day facility. We make use of circuit breaker. Circuit breaker are specified in rating, so you don't you cannot put overrated circuit breaker where it is not needed. So circuit breaker are precise. So when there is a fault, they trip. You don't need to rewire the fuse, the circuit breaker. Unlike the fuse, most people rewire the fuse and put it there. They do more harm than good. So that is why it is now recommended to use circuit breaker in our facility. When there is a fault, the circuit breaker will trip. Before you go back to reset it, you have to ensure that the problem or the source of that problem is eliminated before you can reset it. So we have capacitors and reactors. So they are used to limit fault current. They are also used to prevent exorbitant bill at the end of the month. So they are part of electrical network equipment. We have power electronics. They convert AC power to DC power. They switch quantity of power ranging from few hundreds watts to several hundreds watts. So these are part of electrical network. So we have residential power system. Takes supply from low voltage, like the one we see in our street. They are called low voltage. We have high, medium, and low voltage. So they runs past the building. They operate between 110 and 260 volts, as the case may be. But in Nigeria here, we make use of 220 and 240. Anything outside this is just add plus or minus 5% of the nominal voltage. All right, home and office electrical installation. Like I told you, these are circuit breakers. This distribution board, these are circuit breakers that are used. I told you that fuses are no longer in use because fuse has caused more harm than good. So before if there's any fault, this breaker will trip. You will see it. A section of your building will be having light. Why another section will not be having light is because a fault has occurred. Before you come and set up this circuit breaker, you have to ensure that that fault is cleared. If it's not cleared, the breaker will keep tripping. Within a short while, it will damage the breaker. Some people go ahead and put stick They use broomstick or stick to support the breaker. So what they are doing is putting your house in danger. Circuit breaker is meant to trip when there is a fault. If you now compromise that circuit breaker, it will not trip. Somebody will tell your guys working, you'll be happy that they have electricity or they have power in your building. If you are not there and a fault occurs, that circuit breaker will not trip and will lead to fire and set your building ablaze. Imagine circuit breaker that would have replaced with just about, let's say, 60,000 naira, if it's too much. It now costs you a building of over 10 billion or whatever. You can see why you need to pay attention to what your technicians do on site. When you need to change anything, go ahead and change and make your case known to your management. I change this because of what I envisage it will happen. So you don't compromise maintenance standard in your building. So we have the ring and the radial. Two type of installation exists. We have the ring and the radial. The ring is where people loop cables. They loop cable from one point to another, undermining the source of that electricity or power. If you loop, it maybe a 1.5 mm or 2.5 mm is the source that is bringing the supply. You are looping. There, you will put your oven, you put your washing machine, you put everything. So if a cable is overloaded, it will lead to fire as well. So it will heat up and melt together. If you are not there to quench the fire, it's a big problem for the building. So what people now do is to disuse the ring circuit form of installation, but developers still make use of ring circuit installation because they want to save cost. Because the cost of ring is cheaper than the cost of radar, which is the other one. So the difference between the two, I will let you know. Radar, on the other hand, is you are distributing from the distribution board to where you need the supply. From your distribution board to the kitchen where you use electric stove, from the distribution board to the laundry room where you use electric iron and washing machine. So there is no looping in this kind of installation. Though the initial cost is very, very expensive, but on the long run, you are saving costs. So that's why you need to get involved. If you're employed as a facility manager, you're also a project manager, you have to ask questions. What kind of installation are you doing? You have to know why they are doing this kind of installation. So you are meant to ask questions because once they finish building, they will leave it for you. You start running helter skelter. When you are sleeping, they will call you. There's a cable issue along the ties. Along the ties, there is this so thing that happen. You start breaking ties. You start relaying the cable instead of them to use or adopt the right option, they went and be compromising standard. So that's why this class is very, very important and necessary for you so that tomorrow you know what to look out for. In electricity or electrical installation, we have different symbols that represents our various fittings, like the electric fan, the ceiling fan, the fluorescent tube, and so on. So these are the symbols. So when you look through, you see them. So I want you to master yourself with these symbols so that when you see them as in a drawing, you be able to interpret. It will look as if you don't know, you are just a novice. Anything they tell you, take. You ask question, why is this thing here? Why is this thing there? So with this symbol, you're able to understand how the electricity drawing operates. So this are the symbols as well as their description. So this is cellophane, this is 4 feet bulb, this is 2 feet, and so on. And this is the CCU, consumer control unit, that's the meter. So in electricity design, like I told you, you have to get the specification right, the wattage, everything that you need to know, you have to get it right. You don't assume, you calculate to a standard. for you to spec correctly. So the type of temperature that you need a soundproof generator in some place. Why do I need soundproof? In some places you have dust, while other places you have heat. In the far north you have heat. Well, the generator that will operate here in Lagos closed cannot be operated in the far north Maiduguri. So is it basic generator or soundproof generator? Fire, is it close to the is it close to fire a petrol station, fuel station, or thereabouts? So those are the things you consider. Future expansion, modification, rewiring, portable operating and maintenance costs. Most people, they just see something abroad. They come here to in this part of the world and replicate the same thing, not putting maintenance costs in perspective. For example, people they want to change a bulb, you go and rent crane, go and rent a scaffold to change a simple bulb within a facility that will cost you money. What is the cost of that bulb? The cost of that bulb may be 2,000, but the equipment, the material, the item that you need to change such bulb will be up to 200,000 naira or 150 or thereabouts. So maintenance cost is very, very important. Future expansion. If we choose to expand this building, this size of generator I've recommended or the size of transformer I've recommended, will it be enough to power this facility? If it's not going to be enough, it's your call. If it's going to be enough, it's good. That's why you need to get it right. So create allowance plus or minus so percent for future expansion. So is there any alternative if what within a way people are migrating to solar? My solar equipment will be able to fit into what I have in existence. So these are the things you need to consider when doing your design and consideration. So electrical maintenance, you also put it into consideration, like I explained to you, maintenance costs. Do I need to rent scaffolds or do I need to rent cradle to get this equipment replaced? So all potential electrical conductor, e.g., pipes and fittings, must be earthed. You must earth all your equipment. We'll get to earthing. Make sure they are earthed. Don't assume. They have to be earthed. Don't assume. All conductors must be provided with excess current protection, like the fuse cycle breaker. If you are not there, this equipment will just open on their own. They are meant to protect. Your major equipment must not fail. So it might cost money to put protection in place, but you are saving costs on the long run. Facility management is strategic planning. So you are planning ahead of time. Don't come down to the level of just fix it. I will just want it to work. If it happens, they will still come back at you. What recommendation did you make while you were putting this thing in place? So don't compromise standard. Ensure you stick for what is right. Portable appliance testing. Why do you need to carry out testing in your facility? For example, one of the tests we do is the earthing test, the continuity test. So when you keep record of your testing and you make sure you do it the way you are supposed to do it, you will spend less in your facility, you reduce risk, reduce cost, and you maximize profit. So that's the essence of management, portfolio management. You maximize stakeholder profit, you reduce cost or you optimize cost, and also reduce risk. If risk is reduced, if cost is maximized, profit, there'll be a good turnover. Everybody will be happy. So keeping your record of testing is very key. Diesel test is key. If you don't test your diesel when it's supplied, you can just be accepting diesel that have been compromised. And it will keep damaging your generator. It will damage your equipment. Your AC will not work well. Every now and then the AC the generator is jerking, and it will affect the performance of all your equipment in the building. Your lights are going off, they are burning because your power is not clean. If you do all these things and keep records, at least you will save cost. Are we together? So we have common electrical problems. Flickering bulb. You see bulb, pa, 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 pa. Your bulbs are burning, they are dying, phase reversal, phase loss, triple circuit breakers, and the rest. So these are the table. This is a table for various problems we face in a building, in our facility, and how you can solve them. Lose connection, what do you do? Lose contact, what do? You retight, lose and or firm connection or contact. Unstable or regulated supply voltage, that's high voltage, it's like frequency. Like I told you, if you operate with abnormal voltage, you will run at a loss. Your bills for replacing equipment will high. Your consumption bill at the end of the month will also go high. So you have to ensure that the voltage and frequency are of nominal values or range. That's plus or minus 10% of 220 or 50 Hz. Your bulb is burning. Why are my bulb burning? These are what you should look out for. Also, to a value or range plus or minus the nominal voltage. So phase reversal, when the public utility officers when they come to work on their transformer or there's an external problem, and attempt to connect their cables back, they interchange it. You will now see that your lift, instead of going clockwise, is going anti-clockwise, and your pumps are working in opposite direction. You know that there's a phase reversal. What you need to do is to interchange the load line, or you contact them to come and do it for you. So triple circuit breaker, like I said, ensure that you understand where the problem is coming from before you switch it on or switch back. All right. Consumption monitoring. Why do you need to monitor your consumption? Most people don't pay attention to what they consume. When they bring bill to them, they just pass it to the management and they pay. No, your job is more than that. What you need to do, ensure when you are employed newly, take a stock of what you have been consuming, the bill they have been serving you. Go around to see if people leave their equipment on while they go home. Even the socket that's on your socket on the wall, you see a very tiny light there. Know that everywhere you see light, whether small or big, energy is being consumed, is at a cost. Go around and take inspection. Why is the bill like this? Is there a way we can bring it down? So you do that. So once you go around, you see why the bill is going high. So you take care of those loopholes. Maybe in the next month, if they bring 10 naira this month, next month, because you have done what you needed to do, what you are employed to do, you will be able to bring the cost down to about 9 naira 50 kobo. You have saved a percentage of that cost. These are the things you are going to be using to present to management that you are bringing value to this organization or this facility. So if you don't leave it as business as usual, we're trying to say, which value are you bringing? But go the extra mile, monitor your consumption, and give report at the end of the month to see where you have been able to reduce costs. All right, these are equipment we use for military. Why did you check it consumption as the apartment? volume of that is coming, what you're consuming. So what we can
It looks like you're breaking us. Can you hear me, sir?
me? Yes,
You're
I can
breaking
hear
up.
you.
We can't hear. The line is cracking.
Yeah.
God will help us, oh God, I beg. This line disturbance.
Hello? Is it fine now?
Yes,
Yes,
it's
sir,
okay
it's
now.
okay.
Yes, it's
It's
okay.
better.
It's okay now? All right,
Yes.
sorry about that. It's the network. All right. Like I said, the check meter and the difference between your maximum demand and the check meter will
We
gives
can't
you.
see your slides, sir.
Oh. Can you see it now? Sorry. Is
Yes,
it
it's
better
up
now?
now. Thank you.
Okay.
Yes.
So the difference between your maximum demand meter and your check meter will gives you the consumption in your common area, which can be shared equally to your customers or to your end users. So this is the maximum demand, this is the check meter. So this is normal meter we use to monitor our reading daily. All right. We have extra low voltage in the building. Why do we need extra low voltage in the building? We need extra low voltage because there are equipment that our normal voltage cannot operate, like your card readers, access controls, burglar alarm, fire alarm, and PABS. So what you need is extra low voltage. So you get that from your battery that I made mention of. So that's why you have both AC and DC in your building. The DC operates extra low voltage in the facility. It's very, very important. Extra low voltage can spark you with your job. Imagine that your the battery that is responsible for your CCTV is not okay. You didn't pay attention. So ensure your technician goes around this install equipment. They are all just like if one of you said water is very important. It's like a chain reaction. The weakest point in the chain is as strong as the stronger point. The stronger point is as weak as the weakest point. So this equipment has been installed in a facility. So they need to be maintained. Don't assume they are working. They are not working. So check, that's why you are there. There is what called PPM. You go around, check what you need to check what you need to replace at a regular interval. All right, we have the transformer, the power transformer. What does a transformer do in a building? The transformer, they don't generate voltage. They only switch from higher to a lower voltage. It's a modifier. We have the different sizes. We have the 11 kV, the 33 kV, the 132, and so on. They modify voltage from a higher value to a lower value, or from a lower value to a value, depending on what is required in your facility. So you pay attention to your transformer too, because if they are faulty, if you don't maintain them, they go back easily. So maintenance is key to the functionality of your facility. We have distribution transformer, the one you see around us, they are called distribution transformer. They only help to modify the 11 kV that is coming either to make it constant or to bring it down to 450 or 400, as the case may be. That's what you have in the street. You have the 33 kV in the industry that bring from the main source from 33 to 11, where you need a high demand of electricity. 33 to 11 to 415. So these are distribution transformers. So these are used in high-rise building, mine industry, where you require no maintenance. What you need here is just air. Let there be cross ventilation across this transformer. If you go to this high-rise building, in their substation inside the building, you will see this transformer. They are there. They are maintenance free. What they need is just air, cross ventilation. They expel heat and they bring in fresh air. So that's what you need with this transformer. Transformer maintenance, these are what you check. Transformer maintenance, read magnetic oil weekly. We have monthly maintenance. These are what you check on a monthly basis. You are not the one to do it, but you drive people to do this. You have to ensure that everybody does their work on a regular basis. So maintenance is key. Like I said, when you do a proper maintenance, pay attention what you are meant to do. You are driving down cost. Cost of replacement will go down. And you reduce risk. Business, there will be a good turnaround in business, no downtime. So maintenance is key. Accountant may not want you to do what you are meant to do, but in his department, he has his KPI to deliver. You also have your KPI to deliver. Zero power in your facility, zero downtime. That's what your KPI is. So you have to ensure you maintain this. If the AC is bad as a result of bad supply, accountant will not say you did. He's aware. He can't tell you that he's aware. Did you present it? Did we review together? So you have to make sure you present your case. Facility management is always a business case to win. People don't want to spend, but they don't want to spend, and they don't want the facility to have issue. For the facility not to have issue, all the electrical equipment must be properly maintained at a regular interval. So we have biannual maintenance. These are what you do. People may say, do we need to service transformer? Yes. If they are not there, they will not tell us to do it. We are not the manufacturer. We only use. So for you to have a long-lasting equipment, you must carry out your transformer. Like generator, if you don't service your generator at every 200 or 250 hours, the generator will still work. It might even work for 6 months not maintained, but when it breaks down, you will spend more. What you are supposed to use for maintenance, spend times 3 or times 4 to fix that generator, and there will be a downtime. It will make you look as if you don't know what you are doing. Always justify what you want to do. Present it, push for them. Don't say, oh, if they said we are not doing it, we don't have money. Yes, you don't have money, but this is part of budget. You present your case. So we have annual maintenance, 2 years maintenance, and so on. Well, we'll quickly go to generator before we to round up the class. So what is a generator? There's a difference between a generator and a motor. A generator is a machine that converts mechanical energy to electrical energy. They provide most of the power for electric power grids, like the Kanji Dam. If you go to Kanji Dam or Shiroro Dam, you see a waterfall turning a turbine. That's a generator, a very, very big machine. It's operating naturally with a waterfall. So as long as that shaft is moving and turning that alternator, electricity will be generated. The same principle is applied to the smaller generator we have at home. When you swing that generator on, it's as long as fuel is coming into the carburetor or the injector, the generator is running. The alternator is turning over the stator. The rotor is turned over the stator, and electricity is produced. As long as there is fuel in your generator, the generator will keep working. That's generator. A motor, electrical motor, convert electrical energy to mechanical energy. What does it do? It takes electricity and convert it to mechanical energy, like your grinding machine. Your grinding machine is an example of a motor. All right. Like I said, generator supply current usually have frequency of 50. Anything plus or that is 50, 48, between 48 and 52. If it's above this phase range, your equipment will be working, but at a very high cost. So your technician should not just go take as they take the reading, analyze it. Okay, the frequency, okay, we are still on point. If you see that it's going above 53, 47, below 47, you know that something is wrong. When you check all these things properly, your bill will come down. Your bills will come down. These are the way you can maximize your cost, optimize your cost, and reduce cost expenses. So if you pay attention to this, your bill will come down, honestly. Alternating current, I've told you what alternating current does. They are not, the voltage from this source is not clean. It's not clean. So you need to put extra protection to make sure you get clean voltage from it. We have 3-phase, single phase, as the case may be. Your small generator at home is single phase, while the bigger generator at home, in our place of work, in our facility, are 3-phase generator. Selection of generator determines the total sum of power. Like, how do you do this? All your equipment, check the nameplate, you see the power, the wattage that is written on it. Put all these things together, you know the amount of power that is in your facility. So it is this power that you will use to determine your readings. For example, if you can see my screen, if after putting the calculated total power, you have like 60 watts or 600, let's say 6 kilowatt. Yeah, we deal in kilowatt, 60 kilowatt. Are you still seeing my screen?
Yeah. Yes, sir.
Yes.
Okay. Let's say you check the loads you have in your building. You arrive at 60 kilowatt. And you know, electricity is not generated in kilowatt, it's generated in kVA. So there is what we call 0.8 factor. That's the power factor, right? This is wattage now. That's energy. We have the power factor, PF. So kVA, for you to get the size of the generator in kVA, you will have 60 divided by 0.8. 60 divided by 0.8, it will give you like 75 kVA. This is now 75 kVA. This is the real power of that generator. But are you going to leave your generator size at 75? No. You can make it like plus or minus 5. Let's say plus 5, plus 10% is equal to 75 times, let's say 10%. Do you get? You are going to have like 80 or 82 kVA. This is what you recommend for your customer. Is that taken? Hello?
I'm sorry, I didn't follow this. So sorry, I don't know if you can take it all over again. Sorry.
Let's say equipment A has a, let's say 30 the power rating is 30. Equipment B also has like a 13 as well. So you add these two together to give you how many? 60, right? I want the class to participate. You have 60. You have 60, right?
Yes, sir. Yes, sir.
Okay. That's the total power in your building. I just use these two as an example. The total power in your building now is 60. The equipment in your building has demanded 60 kilowatt. I told you in electricity, we don't make use of kilowatt, we make use of kVA. That's the real power. This is the apparent power, this is the real power. I don't need to go there. I just want you to know how to determine size of generator and recommendation for your customer. So you divide this 60 by 0.8, which I did here. Are you seeing my cursor? 60 over 0.8. What did it give us? It gave us 75 kVA now. So from there, you cannot recommend just, I told you, consider future expansion, future modification. So you cannot leave it at.
Sir, I'm not seeing your screen. Oh.
It's here now.
We are not on that page, sir. That's why we are not following.
Okay.
It didn't move.
Okay. All right. Okay. All right, just hold on. Okay, can you see it now?
Yes, it's here now.
Okay. All right. I said your total load now is A plus B. We give you 60. You see it? Did you see it?
Yes, we are following. Yes, we saw it.
So you have 60 kilowatt now. I said we don't make use of kilowatt in our building. We make use of kVA. You heard of kVA, right? So there's a factor that is accepted generally in the world. That's 0.8. That's the power factor. If you want to determine the size of the generator that can power this 60 kilowatt load, it will be 60 over 0.8. It will give you 75 kVA, right? Hello?
We are with you, sir.
We are with you.
Okay, from there,
yeah, we can hear you, sir.
In my explanation, I said we must give room for future expansion. You don't just recommend the very size that you have determined. There may be plus or something in the building. Oh, we need fridge here. We need something else here. So we will now have to recommend either 80 or 82 kVA to your client. Is that taken?
Yeah. Yes, sir.
Yes, sir.
They divided 60 by 0.8. Okay.
So this applies to all the, yes, this applies to all the kVAs, all the kilowatt, depending on the size of your building and the type of equipment that I install. So just use this one as a reference. Total load is equal to kVA is equal to total load divided by 0.8. It will give you the exact kVA that your building requires. Because of future expansion, you need to give allowance. Is that taken now?
Yes, sir.
Yes, sir.
Okay. Are you still seeing my screen?
Yes, sir.
Back to the PowerPoint.
Yes.
We are back to the PowerPoint, right?
No, sir. We are still in the
No,
Excel
we're not
sheet.
seeing the PowerPoint.
Okay. You see it now. All right. Thank you. So that's that for generator, the size of generator, how to determine it. So fuel management. We are going to fuel management now. I want you to go for 10 minutes break I will come back while we round up with the 80 system. All right, go on break in it by 6:22. We should be back to our desk.
All right, thank you, sir.
You're welcome. Hello, welcome back to the class. You are all welcome back to the class. Can you let me know if you are back by responding?
Yes, sir.
Okay, thank you. Thank you. So, as I've explained, we are on generator now. So, we now understand how we can determine the size of our generator by accumulating all the loads together, aggregating all the loads together, and dividing by, if it's in kVA, in kilowatts, you divide by 0.8. If it's in wattage, you divide by 1,000, and thereafter divide by 0.8. So they are mostly written in kilowatts. All right. So when you are selecting a generator as well, you determine such rating. How possible? Like that's why I say you give allowance on the circuit breaker that you put. So the circuit breaker can tolerate some level of disturbance or distortion, not tripping the generator. But if it's beyond what the circuit breaker can tolerate, it's the limit, it will trip the generator for protection. So we have voltage rating in this part of the world, 240, between 200 and 240. So when you are selecting a generator for your client or your customer, you ensure that it can work with the type of voltage that we have here in Nigeria. So anything outside that, we don't recommend it. Procedure for installation: engage a competent technician or authorized service dealer for your installation. Comply with standard operating procedure. Confirm if the generator comply with latest standard. What does that mean? We are pushing for a clean environment, a cleaner environment. Ozone layer depletion has been a problem in recent time. So what we are doing, a generator that is eco-friendly, a generator that emits lithium or a clean what's it called, emission to the atmosphere. So that's complied to the latest standard. Before you install generator, these are what you check. If there's any damage, report to the supplier. Confirm adequacy of what it has power, the rating of the type of power that the generator, the volume of power that the generator can withstand. So these are what you check before you install your generator. Installation safety: proper installation of the exhaust. Ensure that the exhaust is not facing an apartment whereby the user will be uncomfortable while the generator is on. Adequate ventilation: if there is no proper ventilation, your generator will be doing overheating every now and then. Before you know it, burn off the gasket and knock the engine. Ensure proper ventilation. Give space between the wall and the generator so that fresh air, warm air goes out and fresh air comes in. So these are the things you look out for. You don't just put your generator wherever you want to put it. So it require, if you need to hire the service of a competent technician or expert that will help you achieve all of this. Like I said, this is an alternator where electricity is generated. So it has two components, the rotor and the stator. The rotor is this and the stator is this. They work in opposite direction. As long as there is motion in this compartment, this alternator, electricity is generated. So this requires to be set in motion by a mechanical part where you have the engine. So as long as petrol, diesel is coming into the injector and setting the engine block on motion, the flywheel turn, or the shaft rotates this alternator. As long as it's rotating 24 hours, the electricity will be produced. So it has rotor and stator. That's a component of a generator. Two aspects of generator, two parts of generator. We have the engine side and the alternator side. So one cannot work independently, they work together. As long as you are maintaining your mechanical part of the engine of the generator, also pay attention to the alternating part. Here you have the rotor, the diode, the avion, and co. So if anything is wrong with the mechanical part, it affects the electrical part. Electrical part cannot be set in motion. And if the electrical part is not okay, there is nothing you can produce. So pay attention to the maintenance on a regular basis. Like the electrical part, at least service your alternator every 2 years, general cleaning, dust and other stuff, AVR cleaning, rotating diodes replacement if need be. While the engine parts that lubricate each other, we have 250 maintenance hours or 200. When you need to change the air filter, the oil filter, you change them. Don't say they are still working. So there is an interval to which these things are changed. So you change them when you are meant to change them. If you don't change them, you are not saving money for the company. You are only prolonging the evil day. When it happened, the same company will come at you and say, why did you change? When last did you change your service your generator? Let us see record. That's why record keeping is key. Keep record of what you do in your facility. So when you service and the generator still go, maybe it could be because of overusing or overloading. So you have your record. This generator is designed to carry 4 AC. We are using for 6 or 5 AC. You manage expense. It might work now, but in a short while, it's going to break down. You are amended. If they say continue, let it be documented. They will send you email. Your guy will send you your email, and to be on record that you recommended that this generator is too small, or is not properly managed or maintained. You have requested that this generator should be managed, but your line manager said no. It's still working. Don't use it. Let it be on record. We can't compromise maintenance in our facility. Are we together? So we have the fuel system, the diesel line, the diesel tank, and the water separator. So we have the cooling system as well, this is the injector. So the pipe that connects the fuel tank to the engine. We have the pipe that ventilates the fuel. So in your tank, you see an opening where a pipe comes up like this with an opening bent somehow. So that helps to bring in fresh air into and as the tank is heating up, fresh air is coming. There is cross ventilation there. So everything we do, we take precaution. If you don't allow fresh air to come in, the tank can expand and explode. It will explode. So something that you can avoid with just little amount of money, you allow it to go bad. So we have the fuel pump, we have the fuel injector, and the water separator. These are the components of generator fuel system. So we have the cooling system. We have the cooling system which withdraws heat when generator components are heated up. We have the turbocharger, we have the exhaust, we have the radiator, and so on. Battery also, the battery charger is very key in our facility. So if your battery charger is not charging and you don't know, and maybe your board wants to have a meeting, you assume that the generator is fine. Many people have been fired because of this negligence of duty. They assume that their battery is in order, whereas they didn't check. Maybe the battery is okay, the battery charger could not charge it the previous usage. Now you want to go and start the generator fail, and the board is already sitting. What do you have to tell them? That the battery of your generator is not okay? What kind of facility manager are you? So all these little things, pay attention to them. And let it be documented that someone is responsible you push. As a facility person, your duty is to what's a process implementation. Ensure that you drive process. The process is there, but you are there to drive it. If you don't drive it, your technician will mess you up, and they will not lose their job. It's you that will lose your job. So they are very key. So daily maintenance, these are what you check. You check oil level, you check coolants before you start the generator. This is daily. Ensure they are registered in your job card. What the activity you've carried out, this PPM card, you put it there. Generator oil is okay, water is okay, no leakage. This thing that we are checking, we don't just check for formality. We check so that we can run our facility optimally. So I've told you 250 maintenance, 200 maintenance, as the case may be. So these are what you change. The fuel filter, the oil filter, and co. These are what you change. All right. So these are various maintenance system on your generator and diesel. We have the fuel diesel management. When you have knowledge of your diesel, you have done 80% of your facility. So you know when to reorder. If you don't have, you know how much diesel your generator consumes at every hour. So if you don't know, your technician might be stealing your diesel, or the supplier might be shortchanging you. So if you know what your generator consumes per hour, it will help you establish a reorder time. Oh, if I have like 1,000 liters or 5,000 liters in my facility, worst case scenario on NEPA side or your distribution, your power distribution side, let's say 73 hour, 70% supply of EKEDC or wherever you are listening from. So you go to know when your diesel will be exhausted in your facility. So you will not be tension to start requesting for diesel because you don't have knowledge of how your facility diesel is being used. You don't monitor, you don't do anything, you just, it's finished, you reorder. But if you monitor and keep record, if anything happens, you know what to say. You are not managing your facility with pressure, I mean. So this is why all these things are very, very important. Keeping adequate records, monitoring and maintaining of diesel stock, more conversant with consumption pattern. Like me, if my consumption is out of range, I will ask the technician or the people that are responsible, why do we have this consumption this day? What happened? So they will not have to tell me. We have more people in the facility, more equipment were used in the facility. That is because I have record. I know how my facility perform. All right, let's move on. When you are taking diesel, you check the quantity of diesel in the tank before and after. If it's 10 liters that you have before the supply, and they supply you gauge, and if you now have 25 liters, that means they supply you 15 liters. So that is what you must do. Diesel must be proven to be compliant with industry set standard. We have industry set standard where you use density to measure, where you use litmus paper to check the water content in the diesel. If there's water content, your blue litmus paper may turn to red, or your red litmus paper will turn to blue, depending on the pattern of the litmus paper. So bad diesel decreases generator performance, and bad diesel damage generator. So when you don't pay attention to your diesel, that's when people say, I want to do overhauling, get up pump. No, we have filters before diesel gets to your pump and your nozzles. What are the function of those filters? If your diesel is corrupt, is compromised, I mean, just when you now have to go and be servicing injector pump. The facility managed for years I have never had the cost to go and service at regular interval. That filters the primary water separator that is beside your tank. So you have to ensure that element inside the cup is replaced at regular interval. And you have small other ones before the main fuel filter. So how come your injector is going back?
Sir, I think to be schooling. I don't know if I'm doing
Hello, good evening. So it seems the facilitator is having a network issue. So let's just give him brief.
Okay.
All right, I'm back. Sorry about that. Hello?
Welcome
Please.
back.
Yes, sorry. Please allow me to share my screen. Please allow me to share my screen.
Yeah, you can share your screen now.
Okay, thank you. All right. All right, can you all hear me?
Yes, we can.
Okay, like I was saying before the network interruption. So when you pay attention to your diesel management, you will save more on fixing your generator and overhauling it. I don't like to overhaul my generator because when you overhaul a generator, the life of that generator is 50-50. Even the controller will tell you it can go either way. So the best thing to do is to avoid compromise. Ensure you do what you are meant to do. Maintain what you are meant to maintain at regular interval. All right. So this is generator. This is the generator, a diesel management kit. So what you test for the pH test, the clarity test, the texture test, and the specific gravity. So there's a range to which we accept when we are carrying out a pH test. It's just like the level of acidity and alkalinity in your product. That's between 6.7 to 7.0. That's what is accepted. So clarity test, you can see on your visual inspection, the color of your diesel, the smell and other stuff. So you know diesel that is good by seeing it with your eye. We have the texture test. The test is carried out to determine if the diesel supply is adulterated with kerosene or so. So if they do, you use litmus test to do that and check. So we have the specific gravity test that we all know, 0.0, 0.84, 0.86. So the standard is what you're seeing in this table. So this is what you should accept when you are carrying out, when you are receiving diesel. All right. The last module for today is the earthing or grounding system. Why do you need to earth your building after installing all this equipment in your facility? Why is earthing important? So the reason for earthing is to make your installation or your facility at zero potential. So earthing is like the weaker point of passage of electricity in your building. The earth is assumed to be zero resistance. It has no resistance. That's why if there is a fault current as a result of electricity, it goes through your DB to your neutral to your earth cable to the earth conductor that is buried in the ground. So most people don't pay attention to this point here. So this is the earthing. This is another example. So if there is any fault current, the current will flow from your wherever they are to this cable, this earth cable, to this rod, and to the ground. And why do houses or facilities still get burned with electricity faults? Maybe the earth point is compromised. That's why you need earthing management. Include it in your PPM. Let it be part of your plan preventing activity that you do in a building. At regular interval, you check the level. The level of earth resistance should not be should not be more than 0.000. But because of impurity, it's supposed to be 0 ohms, 0 ohms at 0 point. But because of the purity in our environment, it might increase to 0.04, 0.05. When it's beyond 1 ohms, if the value is beyond 1, you start raising alarm. Because electricity comes with heat. As fault current is coming through that place to the ground, that point where this thing is being heated up and becomes solidified. So it now becomes an opposition to the flow of current. There's no free pathway for the fault current to go to the ground. So what happens? If there's a fault current, it bounces back to where it's coming from, and it will cause damage, either to your facility, to your equipment, or to humans. So electricity flow, as I told you, flow in the direction of weaker resistance, the weakest resistance. If human beings have contact with that installation at that time, the fault can come back and pass through its spinal cord. Maybe that's the weakest point in that installation because it's working with the installation electricity. It could be your home theater or your television, your anything valuable to you. So that is why we pay attention to this. It's part of this module. We give it more attention than there, as every other thing is important. The same way this is important. So what do you do? Is to keep treating this earth, maintaining it at irregular intervals, maybe twice a year or 4 times a year, as the case may be. Depends on the weather condition. Like on the island here, your rate of maintaining earthing might be low because we are in a swamping environment, a waterlogged environment, and it's salty. So the instrument, the material that you require to prevent, to maintain your earth arrangement are salt, that's a electrolyte, sodium chloride or ammonium chloride, depending on what is recommended. You have charcoal. What's the function of that salt? Is like electricity in liquid form. When you dissolve it in water, it makes that place soft and allow free flow of electricity. Clean up the contaminated earth rot. You use charcoal. What does charcoal do? Charcoal is used to absorb impurity. It absorbs all the impurity around that place and make it clean for electricity to pass through. You can also use animal waste. What does animal waste do? They help to soften that environment, to make it soft so that as fault current is coming, it's able to penetrate the earth, make that place a zero level. That's the way we can maintain our earth system. So what's the importance of earth in the building? It helps to reduce electricity cost. Most people don't know why they are building, they are paying heavily. So we have reduced everything. Maybe the fault current, if it doesn't go out, it will become a circulating current amongst your installation equipment. It will be moving around. It's part of your bill because it has not gone out.
I know you won't be generous.
Please put your
mic.
I know you won't be
generous again. That's why it's too dull. You're always fighting the way do. I don't understand.
Please mute your mic, whoever that is talking. I think it's mowing. All right. So the earth plays a very significant role in our facility. It can lead to increase in your bill when you do not maintain it. I'm telling you today, nobody will tell you. If that fault current does not go out of your installation, it becomes part of your energy. It will be reading until you find its way out. If it doesn't find a way, at the end of the month, they will calculate it among your consumption. Are we together? So as I said, the earth is supposed to be on that is zero potential, equipotential. There is no work done. So the installation is higher than the earth, the resistance of the earth. That's why current flows from your installation, from your facility to the earth. Work is being done. So if they are at zero potential now, it is coming, the fault current is coming, there's an opposition, a resistance from the earth. So it will go back to the source. Electricity, fault current goes back to the source where it's coming from. That's why when there is a problem in one of your equipment, like a transformer, your transformer is, let's use a breaker, for example. Your television is having issue, or your AC is having issue. Where do you feed the effect? You feed the effect on the breaker. The AC will trick the breaker because that is the source of power to the AC. It must go back. Just like when you travel, when you go to work, at the end of the day, you are exhausted, you must go back. The same thing with electricity. If the earth is not properly maintained, the current will go, the force will go back to where it's coming from. And along the way, and there's a weak, if there's a weaker equipment, the weaker resistance equipment along the line, it will go to that place and try to come out and bust that television or radio, blow it off, or your computer. Are we together? So earth play a significant role in your facility. Thank you. If you have any question, you can quickly ask so that others can benefit from it. Would you do that with in the next 10 minutes and we'll round up the class? If there's anything you need to know other than this, you can reach out to me through the training manager, then we assist you. So this class has come to an end. It's question and answer now. Go ahead and ask your question. Before you ask your question, introduce yourself, where you are participating from, so that others can benefit. Thank you. Hello.
Hello?
Yeah, ask your question.
Okay, Jack Dominic. So my question goes this way, though I've been trying to follow up the class, but it was breaking. I couldn't hear you properly. So your network was fluctuating. Likewise, Isha. But my question is, for a newcomer, someone with zero experience that is coming to like what should be your first task? Like if your opportunity to gain a job now, what are those things that you do? And what are the condition assessment that you should carry out on a generator to understand the total voltage that your building requires and the total what the kind of journey you use to do that to power your building? How is it being determined?
Okay, as you ask, I will just be answering you. Like I shared with them in terms of generator determinant, you carry out equipment audit, as in power audit, to know the wattage, the power required to power a particular AC, like 2 horsepower AC. You know how many 2 horsepower you have in the building or the facility. You know how many pumps and their ratings you have in the building. When you determine these equipment and you aggregate them, maybe they give you like 60 kilowatts at the end of the day. Maybe that's what you have in total. What you need to do to determine the size of a generator, like I explained to them, is divide that 60 by 0.8. 0.8 is the power factor. That 60 is your apparent power. We don't make use of apparent power in electricity. We make use of real power. Your real power now is kVA. That's why a generator is rated in kVA. Do you get? So you divide that 60 by 0.8. It will give you like 75 kVA. So you cannot recommend exactly 75 kVA to your customer because of future expansion or modification. So you give them like 80 or 85 kVA for your customer. That's how you determine the size of a generator. It can be applied to a higher capacity depending on the load that you have in the building. The key thing here is aggregate all the equipment power and divide by 0.8 and give allowance of, don't overgive, because if you overrate the generator will be having issue in a short while. Thank you. Does that answer your question?
It does, sir.
All right. Further question, please.
Good evening, sir.
Good evening.
Yes, sir. So my question goes.
Your name. Let us meet you and know your name.
Okay, my name is Kayode Olumide.
Okay.
My question goes like this. I just want you to advise a new FM service provider who sign an SLA with a company. What are is that regarding electrical preventive maintenance, under which they told the organization that there should be an insurance coverage. So in a situation where what are the possible mistakes that may happen? Because they have given us the contract. They have given us the contract, but we are just entering. It's not that we know anything about electrical. We just get an electrician. But what are the possible things that the mistake that any possible mistake, being an experienced somebody that we can face, then what kind of advice can you give to us for us not to damage any of their equipment in that organization?
All right, thank you. I will tell you right away. I believe others will learn from this. So the essence to guard against being a victim of insurance or whatever, you have to stick to your PPM. We have planned preventive maintenance that are spelled out by the OEM, the manufacturer. When you stick to this maintenance rule and regulations, there is your insurance, even if they happen, like I said, keeping record of your activities. You document them. Documentation is key here. When you service your generator, you document it. Then this generator was serviced at so hours as recommended by the industry. So when you like this earthing I talked about, when you do your earthing maintenance, put it down. So possible way that electrical equipment can go by is what I'm telling you. Mostly earth leakage, electric shock, naked wire, bridge together. It will result to high voltage and will burn your equipment. So how often do you maintain your panel? How often do you clean your panel? Dust, they may say we don't need to maintain panel. Dust is a resistance. If the resistance is too much, it will be giving partial contact. From there, full voltage will not be, the standard voltage will not be delivered to your equipment. It will start reducing. Before you know it, you start operating your equipment with low voltage, which will damage your equipment. Like I said in my opening class, that if the voltage is low, it will take you longer time to cook your food with your electric stove. But if the voltage is standard, it will take you shorter time to cook to deliver on your cooking. I think I mentioned that when I started this class. What you need to pay attention is sticking to PPM that has been given to you. Don't try to say you are saving costs for the company. I will not carry out some PPM, because when it happens, those are the things that insurance will first of all check. Thank you. Does that answer your concern?
Thank you, sir. Yes, sir.
All right. Any other question before we call it a day? This is 7 o'clock. I don't want to take much of your time. I just need one more question that others can benefit from, then we'll call it a day. All right. If there is no further question, I believe your expectation was met, and if you need further clarification on what you don't understand, you can reach out to the training manager and she will get in touch with me. My details is 080. Are you getting that? My phone contact 080. Let me know if you are hearing me.
Yes, we're hearing
Yes,
you.
we can hear you. Please continue, sir.
080 35 10 4509. Abel is my name. Thank you, and have a nice time in your career.
Hello, sir. Can you repeat yourself?
080 3510 4509. Abel is my name.
Thank you, sir.
Yeah.
Thank you for the lecture. Thank you, and good night.
Good night.
Thank you very much,
All right,
sir.
thank you very much, sir.
Yeah, thank
All right,
you.
thank you.
Thank you.
Thank you everyone for attending the class today.